MSE 302, Mechanical Behavior of Materials. Instructor, Peter K. Lau, Ferris Hall 406, Spring 2004. Spring 2024. The time of meeting, the TA, the office hours, the concept. The textbook is Deformation and Fracture Mechanics of Engineering Materials. The reference books, 2 are given. His office hours are Thursday in person, by email, phone, or Zoom. Hugh is appointment by email. You can discuss homework or exams. Hugh is mainly for homework. Discuss lectures, papers, books, and research, professional interests, careers, and etiquette. The tentative course outline. A. Discussion on course structure. B. Tensile behavior. Inside tensile behavior, definition of strain and stress, also stress-strain curves, also thin-walled pressure vessels, also temperature and strain rate effects on tensile behavior. Tentative course outline continued. C. Tensile tests. Inside tensile tests, introduction, plastic deformation, elastic deformation, property variability, and design safety factors. D. Elements of dislocation theory. Strength of a perfect crystal, the need for lattice imperfection, dislocations, lattice resistance to dislocation movement, the perilous stress, characteristics of dislocations, observation of dislocations, elastic properties of dislocations, partial, superlattice dislocations, dislocation interaction, dislocation multiplication. E. Slip and twinning, crystallography of slip, geometry of slip, deformation by twinning, comparison of slip and twinning. F. Strengthening mechanisms in metals, strain or work hardening, grain boundary strengthening, solid solution strengthening, precipitation hardening, dispersion strengthening, strengthening of steel alloys, metal matrix composite strengthening. G. High temperature deformation response, creep, estimate, rupture life, temperature stress strain rates relations, deformation mechanics, superplasticity, deformation mechanism map, materials for elevated temperatures. H. Deformation response of engineering plastics, polymer structure, general remarks, polymer addition, viscoelastic response of polymers and the role of structure, deformation mechanisms in crystalline and amorphous polymers, strengthening of polymers. I. Fracture, an overview, introduction, theoretical cohesive strength, cross concentration, stress concentration factor, notch strengthening, external variables affecting fracture, nomenclature of the fracture process. J. Mechanics of fracture, Griffith theory, stress analysis of cracks, design philosophy, relation between energy rate and stress field approach, crack tip plastic zone size estimation, fracture mode transition, plane stress versus plane strain. K. Cyclic stress and strain fatigue, fatigue failure examples, cyclic stress controlled fatigue, quantitative assessment of mean stress and notch effects, cyclic strain controlled fatigue, cyclic dependent material response, quantitative description of strain life curve. L. Fatigue crack propagation behavior, stress and crack length corrections with FCP, macroscopic fracture modes in fatigue, microscopic fracture mechanisms, crack growth behavior at delta K, stress intensity factor range extremes, influence of load interactions, environmentally enhanced FCP corrosion fatigue, microstructural aspects of FCP in metal alloys, fatigue crack propagation in ceramics and composites. The group meetings, we have been on Zoom for Daniel Lenoy and for the TA. Discussion of your career development, research, and education paper, writings, paper review, writings, presentation, and research interactions, and members. We also have it for Skype on Sundays. But we also have group meetings on 1:30 p.m. on Fridays on Zoom. We have group meetings on Skype continued at 2 p.m. on Sundays. We have research meetings, lecture, presentations, seminars, and thesis defenses. This is N and O. We have Song of High Entropy Materials. The grading system, midterm exam is 30%, final exam 50%, and homework is 20%. Seems like we have 2 exams. Note that if a person turns in the homework late, the homework grade may be subtracted by 10% for each delayed day. Homework needs to be turned in using computer printouts to be submitted to Canvas. Your grade will be based on points earned as approximated below, which is subject to revision. A, B, C, D. A is 90 through 100, and the rest is given. Read the textbook before and after the class. Strongly encourage you to ask questions in the class. Lecture slides will be presented. Learn the new concept and work on example problems. Homework assignments will be given. The homework must be turned in within 1 week, non-negotiable. Take midterm exam plus a final. Students are expected to attend each class. Be prepared to have read the assigned chapters slides before each class. Participate in discussion and ask questions, and be on time and considerate of others, and turn off all beepers, cell phones, and remove headphones. The exam dates are given. We have the midterm exam on March 5th. We have the final exam on May 13th. We have a closed book exam, and we have a lab tour on March 7th. The class schedule. Hugh Short will help out with these classes. We have a presentation meeting, so the instructor might be out on March 3rd through the 7th. And then we have academic ethics, so intro slides are done.